I have written an algorithm. Let us find out recurrence relation for this one, and we will solve recurrence relation. This is Tn. And inside this, there is a loop. So the statement inside this loop takes n time. Test n, and this is n by 2. So test is Tn, so this is Tn by 2. And this is also Tn by 2. What is the recurrence relation? That Tn is equals to sum of all these. So Tn is equals to 2 times Tn by 2. It is calling itself 2 times. Algorithm is calling itself 2 times. 2 Tn by 2 plus this n. Now if I write recurrence relation, Tn is equals to 2Tn by 2 plus n when n is greater than 1. When n is equals to 1, it is some constant, or just take 1. See here, if you observe, I have taken n greater than 1 because this is dividing function. So the smallest value after division is 1. We get 1. So that's the reason I am taking it as 1. In the decreasing functions, we were always taking it as 0. Here also I can take 0, but solving recurrence relation will be difficult. When we reach till 0, then everything may become 0. That's the reason we stop at 1. That is the reason we are taking it as 1. If it is not 1 also, if it is 0 also, you can make it as 1 and prepare a recurrence relation. And this can be solved if this is made as 1. N of n is 1. This recurrence relation is very important. Time complexity of some of the algorithms can be represented by using this recurrence relation. This is very important. I will solve it using tree method, recursion tree method. Tn. This is calling itself 2 times and then n. So okay, n I will write it, and this is 2 times it is calling itself. So this is Tn by 2 as well as Tn by 2. To make it simple, what we do is, see, this is Tn. Tn 3 steps are there. So what is the time of Tn? Tn plus these. So instead of writing Tn, what we do is, first step is n. Then whatever the time we get in n by 2 and the time taken in n by 2. So I am avoiding writing function Tn completely, just n, then n by 2 and n by 2. Then what this? Again it will call itself 2 times, n by 2 square and n by 2 square, and this also n by 2 square, n by 2 square. Then this will call itself for n by 2 cube and n by 2 cube, and this also n by 2 cube, n by 2 cube. This is n by 2 cube, n by so on. How long? This will continue until they become 1. They become 1. So how long we do this? We say that this we will do it for 2 power k times. K times. N by 2 power k times. So this we will repeat for k times. This will repeat for n by 2 power k times. So total how many steps are there? K steps are there. K steps are there. And in each step how much time it is taking? N. And this is how much? N by 2 plus n by 2. N only. This is n. This is also n. How much time this is taking? N by 4, n by 4, n by 4, n by 4. 4 times. It is n only. N by 8, n by 8. 8 times. So this is also n. N. So this is all n. How many times? N into k times. So what is this k? See, we assume that n by 2 power k is equals to 1. So n is equals to 2 power k and k is equals to log n. Yes, therefore this is n log n. So the time for this is order of n log n. So the time taken by this algorithm is n log n. So this is another way you can prove it using tree method. This is the first time I am writing it like this. Every time I was using Tn, you can watch previous videos, other videos also. I am just writing the time. Instead of function, I am just writing the time. So this will be done for k times. So every time the total in this level, total is n. So that will be k and time, and k is log n. Next, I will solve it using back substitution method. I will remove everything and I will solve this recurrence relation using back substitution method. Now, let us solve this recurrence relation by substitution method. I'll take this recurrence relation Tn is equals to 2Tn by 2 plus n. Then I can know the answer if I know Tn by 2. What is Tn by 2? Since we know Tn is 2Tn by 2 plus n, then n by 2, in place of this if I write n by 2, t, this will be n by 2. So n by 2 and again by 2, so this becomes square plus n by 2. So that's it. This we will substitute here. So this becomes what? 2. What is this? 2Tn by 2 square plus n by 2. So 2 as it is. At this place we have substituted this one plus n as it is. This was our first equation. Remember this. If I open this, 2 square Tn by 2 square plus 2 gets cancelled and n plus n. So this is the second equation. Here even I can write 2n. So n I have written it. This is Tn. Now I have to find out this one and substitute here. Let us see what is Tn by 2 square. So here I write Tn by 2 square. So in place of n by 2 square, so 2 as it is, t, n by 2 square, so n by 2 square, but one more 2 is there, so 2 cube plus n by 2 square. This one has to be substituted here. So what this will be? 2 square and that part 2Tn by 2 cube plus n by 2 square. After this 2n. So only this portion I have substituted. So this became this in bracket. Open this one. So this will be 2 square into 2 cube, Tn by 2 cube plus 2 square gets cancelled. So n, already 2n is there. So this will be 3n. Third equation. That's it. 2 times I have substituted each. Now if I continue this for k times, I say that I'll repeat this for k times. I'll continue writing here. If this is continued for k times, then this will be Tn. 2 power k, 2 power k. T, n by 2 power k, n by 2 power k. This is cube, and this is 3n. So plus kn. And we assume that this has became t of n by 2 power k has became t1. So therefore n by 2 power k is equals to 1 and n is equals to 2 power k and k is equals to log n. This is our assumption. Now what this is equal to? Tn 2 power k What is k? 2 power k. Okay, let it be 2 power k only. Then what is this t1 plus kn? Now we know what is 2 power k? 2 power k is n. T power t of 1 is what? 1 plus n as it is. What is k? Log n. That's it. Now Tn is n plus n log n. So the highest term is this one. So it is big O of n log n or theta of n log n also you can say. That's it. This is the recurrence relation. Solution of recurrence relation is n log n. This is a very important recurrence relation. Again I am telling you. You should know 2 Tn by 2 plus n if you have, then this will be the result. That's all. We will end recurrence relations here. Next I will show you Master's theorem for dividing functions. The functions in which this is getting divided. And let us see how we can directly give the answer by looking at a recurrence relation. So for that we will look at Master's theorem. So next video is on Master's theorem.